Hello, everybody. Welcome to day 11 of the Sound and Light Unit. Today, we're going to focus mostly on colors. Quiz tomorrow on days 9, 10, and 11 on the electromagnetic spectrum, and then the stuff that we're going to be doing today. And we have our exit ticket today due at 2:30. So today we're going to be talking about how light interacts with different surfaces and matter, and how light interacts with lenses, and specifically concave and convex lenses and mirrors. So when light strikes any form of matter, the light can be transmitted, absorbed, reflected, or a combination of those. Those are a couple of the things we talked about earlier in the week. So obviously, transmitted means it's being passed through. Absorbed meaning that the energy is being stopped there, and all the information that goes with it. And then reflected is it's being bounced back, directly back, or at an angle, depending on what kind of surface it's bouncing off of. So when transmission happens, there can be a couple of different things. Dispersion is when white light, meaning light that contains all the different colors of the rainbow, when you add them all together, you get white. When that passes through a medium, whatever it might be, dispersion can happen, and this is where light is refracted into its different colors. So white light would pass through a prism. I think we've all seen this at some point, whether it's through glass or something like that, or a water droplet, and we get the light split into all the different colors of the rainbow. And obviously, that's how rainbows occurs. They get dispersed through water droplets in the air. So that's where normal white light that contains all the different colors of the rainbow gets split into its different components. There's also refraction, where that's the bending of light rays. Things can get a little bit goofy. They can look a little bit odd. Remember, we had that pencil in the water example from a couple days ago. And then there's polarization, and that's when the electric fields in the light are lined up. If you have really nice sunglasses, a lot of the times they are polarized, and so they'll reduce the severity of the light or the intensity by lining up a kind of like a shield with one of the electric field lines. So right down there at the bottom is a really good example of dispersion of the white light. So if you think about this water droplet or this prism is kind of always the thing that everybody goes to. It splits it into all the different colors of the rainbow. We look at refraction. I think these are called sundogs. These happen where the white light from the sun kind of gets bent, and now we get this ring around the sun. That's where that comes in. And polarization, we can end up with a couple of lenses, and I wish I could show you this. We've got a couple of really cool polarizers, but a polarizer will only allow light in one direction. So you can see that light is kind of all over the place. We got wavelengths going all over the place, and it will only allow light to pass through it if it's traveling in a certain direction. So it's like a filter. It will just filter out light that is not going in that direction. Lenses interact with light a little bit differently. Concave lenses, where the center is kind of thin and the edges are a little bit wider, they refract light and they cause it to spread out. So if you wear glasses and you're nearsighted, these are the kind of glasses that you're going to wear. They're going to disperse that light, and it's going to kind of make it focus on a different part of your eye. And that incoming light just kind of spreads out as it goes through a concave, or sometimes called a diverging lens. So concave lenses cause it to spread out. Concave uh, from concave mirrors cause reflection, and mirrors do cause reflection. I think we've all done that. Um, they reflect the light and they cause it to converge. So we have concave lenses disperse, concave mirrors reflect. And as that light hits the mirror, the angle of incidence equals the angle of reflection, and we get all that light diverging somewhere. So if you've ever seen mirrors that look like that, they often focus light in one spot. A lot of makeup mirrors do this. That's why you can get the big magnified look in a makeup mirror. Convex lenses, this is if you're farsighted, if you're like me, it actually causes the light to converge past the lens. So it gets a focal point back behind the lens. So the light comes in and then it comes together. All right, and that allows it to focus on a different part of the eye. So that refraction causes the light to converge. It moves closer together as it passes through. And the thicker the lens, the stronger the convex lens, the shape of it influences too. The more drastic the refraction is going to be. Convex mirrors do the opposite. So these are a lot of times you see them on cars, on the mirrors, like the side mirrors, or in if you go to like Costco, they have these mirrors up so people driving forklifts can kind of see around corners. They cause the light to diverge after it's hit, so you can see things that are a little bit outside of your field of view. If like if you go to Target, they always when I was growing up, I always noticed that they had convex mirrors over security cameras, and so you couldn't really see anything. So there's a couple of different ways that convex mirrors are used. So I'm sorry I don't have the exit ticket on here, but the exit ticket is due today at 2:30. Let me know if you have any questions. If you have a meeting today, please make sure you're ready for it. If not, you just make sure you get signed up. If you missed one, sign up again. It's no big deal. But we want to get these done by next Friday. And if there's something with the timing that doesn't work out for you, please just reach out to me. We can make it a quick informal thing. We don't have to have an appointment, and it can be outside of that kind of office hours time. All right. Have a fantastic day, everybody. Good luck. Enjoy the rest of your day.